Okay, good morning. This is Mr. Henry Clement for your Year 8 Secondary Science 2, the particle theories. Okay, this is the books I put it in my homeschool center. I let the student to use. So today we shall discuss a little bit about the particle theories, okay, following the syllabus. So I think you have learned yesterday as well when I draw some solid and liquid and gas particles. Okay, so the solid will look this way. They are lined out in a very good pattern. Okay. Actually, you can draw also as well. Close it together. No. It's the same. Touching each other. Okay. So the property of these solids that they have a definite mass. That means the mass is there. Definite net mass means that this mass is 1 kg is 1 kg, you cannot change one. Okay. So for example, 1 kg. So this one will be given 1 kg. Okay. Secondly, this one is not only in this way, but actually this is x, this is what, this is x, this is y, and then we have the solid one. So actually it should be like a solid. Solid, can you see? This is a solid. This is a solid. Yeah, it's a solid, can you see? So we call it, this is a definite mass in a 3D structure. 3D means the 3 dimension. In many solid, the particle are, this one is like arranged in the orderly pattern. So this is so-called orderly pattern. The name, we give that the name lattice. This is about the property and arrangement, then arrangement part. Then we go to the movement part. For the movement of the solid is just vibration. That means that they can just vibrate, you know, cannot move. Vibration or vibrating, that's why I can change it to vibrating, which is consider move only a little bit. And then, in other words, you can use a phrase like that: move, vibrate, to and flow in a fixed position. Arrangement, movement, and then for year 8, we need to learn another thing, which is called attraction force. Okay. Strong and stop the particle from moving around. And shape cannot change. And then close together. So that cannot be compressed. Okay, so can you see? As compared to yesterday, yeah, just 7 ticks. The year have this feature now. Okay, because the attraction hold them together, you know, they are not loosely far away. Okay, so they are already so close. So then you cannot, the attraction hold them together. So you want to change their shape, also cannot hold them so strong. If you want to compress some more, because they are so close, you cannot compress anymore. You see? Now we go to the liquid. The liquid, you may draw this way. Just look at a randomly thing. And you can draw it closely, but be careful, you must touch in your exam. The second one is the best you want to do in your exam, but actually they appears maybe the top one and the second one will do. Okay, so you need to do it closely. Okay, how should we write A in sentence? Just now, definite mass and also definite mass and volume. Okay, so this one you have the same thing. Arrangement part. You have the definite mass and volume. Okay. And they do not have lattice structure. For the attraction force part, this is weaker than solid, but still holds them closely, so cannot be compressed. But because this is weaker, so cannot hold them in fixed position. So that their movement can moving around each other. That means you can write them as they can slide past each other. Cannot, so not fixed position means that the ship can change and varies following the shape of the container. Next, we'll have the gas. Okay. Or you can draw it another way, which is with a different direction of arrow. This one will do. So the gas also have a definite mass, but not volume. This is arrangement. The volume can change. Okay, let's talk about the attraction. The force, can you see the word here? The forces of attraction between particles are very small as compared to the kinetic energy of the particle. This is because the attraction force is small as compared to the kinetic energy to move away, because they vibrate more and they have the movement far faster than the force far greater than the force attraction between the particles. So that they move on how they move. Number one, fast. Number two, away from each other. No attraction at all, you can see. This one, compare. Number three, all direction. All direction means what? Means that randomly. Freely. You can use another word. So now, the arrangement here you can see, therefore they are far away so that they can be compressed. And following the shape of the container. So yesterday we have do a very good exercise on the melting, freezing, evaporating, boiling, and condensing. I think friends can look back to yesterday's video, okay? And today also we do some sublimation and dissolving. So I won't further that. You can always get your books, buy some books, and then go to study that, okay? Today we are talking about a little bit more, which is the gas pressure. But however, I should go through it review from this book. Just this book, I think. Okay, I read fast for you. When the solid is heated to its melting point, it loses shape and start flow. This is due to the energy supplied by the heat, making the particle vibrate more strongly, so they push each other further away. This weakens the force attraction between the particles and allow them to move around each other. This is solid, now become the liquid. Freezing. When the liquid is cooled to its freezing point, the particles lose so much energy that they can no longer move around each other. The only movement possible is the vibration to and fro with one position in the lattice, and the liquid now becomes a solid. Evaporation. A liquid can turn into a gas over a range of temperature without boiling through a process called evaporation. In this process, some of the liquid at the surface change into the gas and mix with the air. It happens because the particles in the liquid have different amount of energy, and those with the most energy move the fastest. At the surface area, this fast-moving particle break away from the other, escape into the air, and form a gas. Boiling. When the liquid reaches its boiling point, bubbles of gas form in it, which rise to the surface and burst into the air. This process is called boiling. If the boiling liquid is heated more strongly, its temperature does not rise, but it boils more quickly. The heat makes all of the particles in the liquid move more quickly, and the faster moving particles escape from the surface of the liquid and collect in the liquid to form bubbles, which then rise to the surface and burst into the air. The fast moving particle released from the liquid form a gas. Boiling. Boiling is mean happen throughout the liquors. Because the rising bubble in the liquid, okay, is the gas that form at the bottom of the flask. Condensing. If a gas cools down far enough, it condenses and forms a liquid. The particles in the gas lose some of the energy and allow them to move so quickly, and they slow down so much that they can no longer bounce off each other when they meet. They stay close to each other to form a liquid. Then we have the sublimation. A few substances can change from liquid to a gas or gas to form a solid without forming a liquid. This process is called sublimation. When the solid changes into the gas, the force which bind the particles together are quickly lost, and they move away from each other completely. When the gas forms directly into a solid, the particles lost their energy so quickly that they come together and they're held by the forces between them. This is the stuff. This is our done in the fume cupboard. When you do some poisonous gas, you must always use a fume cupboard. Okay, the fume cupboard will convey the suck the poisonous gas away. Dissolving. This one also we do it yesterday. When a solid dissolves in the liquid, okay, the liquid is called a solvent. It seems to disappear into it. If this is colored substance, it may color the liquid. However, it does not disappear. These particles simply separate and spread out through the liquid until equilibrium. This is possible because the liquid has a gap between its particle, and it is into them that the particle of the dissolving substances pass. Okay, we focus on today's things, gas pressure. Okay, we should do the gas pressure. And then this is the new thing for today's class. Okay. Allow me to read this one. Solids can generate pressure. Thinking of a brick pressing down on your toes, liquid can generate pressure too. A dam has to be built with a thick wall to withstand the pressure of the water that collects in the reservoir behind it. Gas also generates pressure due to the action of their particles. A gas contains millions of quickly moving particles every second. Large number are bouncing off the wall and the gas container. The force of these particles as they push against the surface generate a gas pressure. So can you see, this word is important. The force that of this particle as they push against the surface, the keyword is surface, generate the gas pressure. So sometimes this is the particle moving so fast, hitting the thing. Okay, so if something is very hard hitting that, can you see this is very the sound is very loud. It's a big pressure. Can you see? But if the same thing, but when I hit, this is so absorbed, this is so soft. This is so soft. So that's okay. So if the wall is not rigid, the wall is flexible. So the gas pressure, even though the speed is very fast also, but it doesn't give you a measurement of the gas pressure. So the push against the surface, this is the keyword, Okay. So this is the concept you need to know. Okay. If the gas is heated, the particle move faster and bounce off the container surface more frequently and with more phases, so the gas pressure rises. When the gas is cool, the particle move more slowly. They bounce off the container surface less frequently and with less force than the gas pressure fall. When the gas is squashed into a smaller volume, its temperature is kept the same. The particles have less space to move. They bounce off the container wall more quickly and the pressure rises. Okay, to show this one, I think I should show you a experiment. Okay, for example, I have this container. I should have the container in even size. Okay, so this is a fair test, right? Okay, it's around a bit. This is the size. Okay, this is the size, and then this is double the size. This is double the size. Okay, so the first one is compared to the first one and the second one first. If I move around 20 strokes, okay, can you see? This is a very short one. Everyone is this is this length 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yeah, 20. If we this length, each stroke which mean that the speed of the line is this length, okay, as compared to the longer one. Can you see? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Can you see? The line is more, and then they will hit the wall, I think, as also twice because of the faster speed in the 20. So this is with the same volume, the fast moving particle create a greater pressure. With the same volume, the slow moving particle create a smaller pressure, assert the pressure to the wall. So let's see, we try using this length and try 20 on this larger volume. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So if also 20 line of this length, okay, you can see this is more loosely back and then there's more space. So they will assert less pressure as compared to this. So the higher pressure will be this one, number 1, this is number 2, and then this is number 3. So the volume bigger, with the same speed, smaller volume have the high pressure, but this tend to have a lower pressure. Okay, this is the drawing for this to explain this. So we should come to a new term which is called atmospheric pressure. So you may not feel this atmospheric pressure, you are used to it. Okay, this is my skin. I never think that my blood pump from inside. Okay, and then there is a pressure there. Okay, but actually there is a pressure. If not, if the atmospheric pressure is low, my heart pump the blood into the hand will be like look like bigger, just like the balloon. If this pressure is higher inside than the outside, so you will just like a balloon. When you blow it, the pressure inside the balloon is higher than the atmospheric pressure, then it will be inflated. Okay. The atmosphere is a mix of the gas that covers the surface of the Earth. The atmosphere is about 1,000 kilometer thick and push on every square centimeter of the Earth's surface. This push is a force on a specific area. The square centimeter and known as the atmospheric pressure. It is measured as Newton centimeter square. The atmospheric pressure on the sea level is called standard pressure. It's about 10 Newton per C. That means each 1 cm square, there will be a 10 Newton. Okay? It is the pressure in which the boiling point of any substance is measured. At the top of very high mountain, the atmospheric pressure is less than the sea. Okay, this means that this is the Earth, and this is the house, and this is the atmospheric pressure, the press down to it. So maybe you have 1,000 kilometer thick of the pressure. But if this is a mountain, then you have the house here. So the pressure is maybe 400 kilometer, so it's less pressure. Do you know that when we go to the high mountain, we need to use the pressure cooker so that to cook the rice, so that the water can boil at only 100 Celsius, If not, they will boil earlier than 100 Celsius. If the flask containing a liquid connected to a vacuum pump and some of the air above the liquid is sucked out, there is less air inside the flask to push on the surface and the water pressure is smaller. Lowering the pressure and lowering the boiling point of the liquid. Okay? The reduced air pressure allows evaporation to take place more quickly and less heat is needed to make the liquid boil. Okay? Lowering the atmospheric pressure on the liquid, lowering the boiling point. The lid of this pan of the boiling water is being pushed out by the steam. Boiling and high pressure. When the gas gets hot, it expands and increases the pressure on the surface around it. If water is boiled with a pan with a lid, the steam escapes from the water push on the lid to make it rise, allowing the gas to escape. Pop, 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 then they will escape. Okay, now we go the last for today, which is a diffusion. This is Mr. Hedy Clement for your class on Year 8. I hope that you enjoy this class. Okay, you may take this one as a revision preview. Okay, I hope that it can help you on your learning path. Diffusion. Diffusion is a process in which one substance spread out through another. It occurs in liquid and gas. For example, if you put a drop of ink in the beaker of the water, just you mix with some orange juice or something, or orange concentrate, the ink will spread out through the water by diffusion and color it. Okay, so firstly, the thing will be, if this is a crystal, if this is an ink, then you will drop it this way. But if this is a crystal, then firstly they will dissolve first. After they dissolve, and then the particle from the water is keep on moving, because the attraction force is not that strong as the solid. So all the water particle will hit the dye particle, okay, this color particle. So this color particle also will move a little bit, okay. So they will mix together until one stage which is they have evenly, which is called equilibrium. Equilibrium. It means this is not stop moving, but it's just the movement of the water particles, the solvent and the colored dye, they are equal. They are equal. That means there has 1,000 particles from up to down, and then at the same time, there will be 1,000 from down to the up. Okay, this is the whole idea. The gas escaping from food contact cooking in the kitchen can be moved by diffusion to another room in the house. The moving particles in the different liquid move around each other, and the particle in the different gases bounce off each other. This movement eventually spread all the particles in one substance evenly through the other. We call it the equilibrium. Liquids are denser than gas, and this makes diffusion in liquid much slower than the diffusion in the gas. Okay, if I spray the perfume here, the perfume is so concentrated here, there's none here. So the particle air will try to hit this particle, and also my pulse will hit the perfume. The perfume will go up, and then eventually the diffusion happens in the gas. Okay, so this is Mr. Henry Clement. Today and yesterday we have learned this solid, liquid, and gas. Also, we learned about the process. Okay, and yesterday I have mentioned that the melting, boiling, all these are physical change. Nothing to do with the chemical change. Okay, and then today we add one thing which is called air pressure. I hope that you like it. Okay, that's all for today. Thank you for joining. Okay, this is Mr. Henry Clement. If you have any full notes, okay, or tuition, you may always contact us or visit our dear friend Colorful Note or Henry Clement website page. Leave a message to us. Thank you very much. Bye.